And today we're going to talk about migratory aptitude. What is migratory aptitude? In many reactions like Hoffman reaction or Curtius rearrangements, identity of the group that migrate is quite clear. However, in certain other reactions like Beckmann rearrangement, there are more than one choice. In such situation, the question of which group migrate depends upon these several factors, such as the geometry of molecule. In case of Wagner-Meerwein or Pinacol rearrangement, there are many choices as substrate contains several substituents that have similar prosperity of migration. Such reactions are used for the study of relative migratory aptitude. In this example, hydroxyl group is lost from the carbon bearing two phenyl groups as it provides more stable cation. Then the stability of the carbocation is enhanced by the group in this order. Aryl group have the most stability, then allyl, then hydrogen. So the hydroxyl group which is going to be lost would be the one which is attached on the carbon bearing two phenyl groups instead of the carbon bearing two hydrogen atom, because the carbon bearing two phenyl group is going to be a tertiary carbocation after losing hydroxyl group, while the carbon containing two hydrogen groups is going to be a primary carbocation. And we all know that a primary carbocation is less stable than a secondary and then tertiary. So tertiary carbocation is most stable. So in Pinacol rearrangement, this kind of reaction is going to happen and hydride is going to migrate instead of phenyl. In order to study migratory aptitude, the substrate should furnish same type of carbocation within the same migratory migration wherein the migration occurs. Many factors control migratory aptitude. These are conformational features, the relative ability of the groups at the migration origin that can stabilize the developing positive charge. In the following example involving the decomposition of tosylate, only phenyl group migrates. So the phenyl group in the following example assists the departure of tosyl group. This tosyl group left the carbon. This tosyl group left this carbon, and this carbon is going to be the primary carbocation. No, not primary, but tertiary carbocation, secondary carbocation. And after this, as forming a secondary carbocation, this phenyl is going to replace this position as and migrate from this position to this, and after that protonation, and after the migration of phenyl group, this is going to deprotonate and form the olefinic bond. Now in this related alkene, upon the treatment of an acid, a competitive migration of methyl and phenyl groups are noticed. So the first thing in this reaction is that this carbon right here have two methyl and one phenyl group. In the previous example, we have phenyl group migrated, but there are two possibilities in this following example. As we can say, there are two products forming through here we have methyl migration and here we have phenyl migration. So this is called as competitive migration of methyl and phenyl groups. Aryl group exhibits higher propensity for migration than that of alkyl groups. Migratory aptitude of hydrogen is unpredictable since the mixture of migrated products are obtained. In case of aryl group, those with electron donating substituent at the meta or para position migrates preferentially over those who contains substituent at ortho position. Aryl group contains electron withdrawing group show the reduced migratory aptitude. So that's the migratory aptitude. Next, we're going to talk about nucleophilic rearrangements. So that's all for today.